Assalamu alaikum. So welcome to our project presentation, and in today's topic we have selected our diabetes prediction project. So in our presentation, I along with my group mate Nafisa Meherin and I am Mohammad Tashrif Khan are going to present our uh, model. So our ID is my ID is 21301351 and her ID is 23241114. So at first, why making this project? So making this project is actually will help us predict diabetes beforehand, and which will be very beneficial for reducing the cost, especially for the poor people who cannot afford to uh, invest very on their health system. And it will also make us sincere to our personalized healthcare and optimization and development. And also it will help us to let us know about the harmful cautions of it by showing us the percentage of the problems from the data set. And if I tell about the data set, we have chosen a female data set, and here in the data set there is shown that percentage, glucose amount, blood pressure, skin thickness, insulin, BMI, diabetes, and age, and lastly outcome, which will represent our diabetes, a person is diabetic or non-diabetic. So in the pre-processing steps, we have selected some data cleaning step. Here in the data cleaning, we have checked if there is any null values or missing values and replace them with calculated or estimated value. Then comes in feature scaling, where we have used uh, standardization standardization we're rather using normalized data, so normalization. So here standardization will enable us to transform features by subtracting their mean and then dividing by their standard deviation. It also has some features to be on the same scale, and it also enables some reduced bias, means features with large magnitudes can bias the model towards them, and standardizing features reduces this bias by ensuring all features have the same scale. Then handling imbalanced data, which will in cases where the data set has imbalanced classes, techniques like oversampling the minority class or undersampling the majority class can be applied to balance the data set. Then we have used train test split. In to train our data more, we have used 0.3 in the test size, which will uh, give us 70% trained data and 30% test data. Then comes our SVM model, which is our only model used here. Now, question is why we have at first question is why we have chosen this model. So it is actually called support vector classifier model, or SVC, and it is very powerful supervised machine learning algorithms, and it has some key characteristics which are like linear and non-linear classification, maximizing margin, support vectors, kernel trick, regularization parameter. And we have mainly used this model for handling high dimensional data and ability to handle both linear and non-linear classification tasks for the project. So SVM model basically creates a hyperplane to separate between positive means like 1 and negative means 0 outcome levels. And here 1 means diabetic and 0 means non-diabetic. So having a hyperparameters like kernel type to interpret the data set will give us a very optimal performance here. So this is why we have used SVM model. And lastly, for accuracy score, is it enough for an imbalanced dataset? Answer is actually no, but we have used this most commonly thing for our project to make it run correctly. But if we have an imbalanced dataset uh, for a classification model, So it accuracy alone might not be sufficient here. Then we can go for precision or F1 score to simply predict all the classes more accurately and properly. So that's all from my side. My next presenter will present the rest. Thank you.
Assalamu alaikum. I'm Nafisa Merin. My ID is 23241114. To Now I'm gonna talk about accuracy for our dataset. We use accuracy for our diabetes prediction dataset. Basically, the points we're seeing in the slideshow in the slide is depicting how accuracy helping us with the dataset. Basically, accuracy is easy to understand, then interpret, and like it is calculated as the ratio of correctly predicted instances, correctly predicted instances to the total number of instances. Like this, basically, this one thing makes accuracy a convenient metric for a quick assessment of model performance. Then there is this other benefit of accuracy, which is that it treats both classes equally when you are in a balanced data set, because like it's a balanced data set, right? And you have like it will it will give the equal importance to correct prediction no matter what class it is, like positive or negative. And also in a balanced data set, accuracy can be a reliable indicator uh, of how well a model is making correct predictions. But like if the data set is like a bit imbalanced, it's suggested to use another metric, which is basically precision. You'll get a better result when you are using precision for other data set, like this one. Now we used SVM for our diabetes prediction. For SVM, I will say that SVMs provide clear decision boundaries. This is why we used SVM in this dataset. SVM has the ability to handle non-linear relationships, and like it can perform well in the high dimensional spaces. And like yes, the other machine learning algorithms are maybe suitable for diabetes prediction, but SVM will give you a better result in this scenario. Then I'll say that in the like I'll say that the as diabetes prediction had like various kind of features in it. uh, uh, yes, diabetes prediction has various kind of features in it, um but like they're like SVM perform well in these spaces because it has like a ability to like use the like it has the ability to perform well in high dimensional spaces. And then like it will provide options for tuning parameters to address imbalanced data sets, such as adjusting class weights or using different kernels to handle varying degrees of complexity in the data. Mm, Then we researched more and we have found out that the model we are using, it will help us with model ensemble, like experimenting with different techniques like bagging or boosting or like stacking multiple SVM models to combine their predictions, potentially like enhancing the overall performance of the model. Then we can address the imbalanced data. We can explore techniques like oversampling, undersampling, or using like different class weights to handle the imbalance and improve the model's ability to predict the minority class. Uh, Wait. Also, like we can do cross validation, like we can use k-fold cross validation to uh, assess the model's performance across multiple subsets of the data. This helps in obtaining a more reliable estimate of the model's performance. Also, we can, if we like continue evaluation and updating, like we oh like we will, like we can reevaluate the model's performance with new data, and consider retraining the model periodically to adapt to potential changes in the data distribution and like in the domain. um yeah, thank you. Like that's all from our side. Thank you. Assalamu alaikum.